basically, in the past, we just kind of like put our sewage in the water. We put, we just, threw stuff we didn't need anymore, whatever, in water. And the theme was kind of like the solution of pollution is dilution. So if you put a bunch of water, you put a bunch of stuff in the water, oh, we don't even know it's there because, Um, but now they found out, like this picture is, I don't remember exactly which river this was, um, but this lake, like there was this issue, and it like caught, it was so polluted, it like caught on fire. And that was basically when the United States was like, maybe we need to work on this water pollution issue. Maybe it's a little worse than we thought. Um, so that's a couple of water acts, historical water acts. The Federal Water Pollution Control Act of 1948, it basically just provided assistance to local governments. And then the Clean Water Act, this is our big one. This is one of those ones that I would like remember. And it basically gave the EPA the responsibility of restoring and maintaining the biological or the integrity of U.S. waters, whether that was biological or chemical or what they needed, whatever they needed to do. Okay, I just want to make sure. Okay, this did not upload well, but basically we have two types of sources of pollution. I know we've been doing some discussion posts about this, but basically point sources are direct discharge and they're easy to identify and monitor. If you can point to something and say that's where the pollution is coming from, it's a point source. So a factory or a power plant or a coal mine, anything, those are like concrete entities and you can go, that's where all the pollution is coming from, that factory. Um, that's considered a point source. A non-point source is something that you cannot point to and figure out and know where it's coming from. So it's poorly defined, it's scattered, it may be from lots of things and kind of combined together. Like for example, like runoff, right? Runoff can come from lots of places. It's not like we're like, oh, it's definitely from that house. So runoff is a non-point source, stormwater drainage, stuff that comes from the atmosphere, because the atmosphere is everywhere. Um, those are kind of things that are considered non-point sources, and they're a little harder to regulate because they are kind of all over the place. You can't just say, oh, well, we're going to stop that factory from polluting. It's hard to be like, oh, this homeowner right here, we need to stop him from fertilizing his yard so much. So it's a little more difficult to regulate. So the sources of water pollution, a lot of it comes from like wastewater, and not necessarily wastewater like we think of in the United States, but like wastewater where people are going to the bathroom directly into the river that they also get their water from, their drinking water. And so the biggest widespread water pollutants, not necessarily in the United States, but worldwide, are infectious diseases that are spread through water, like cholera, diarrhea. It sounds kind of silly and people laugh about diarrhea, but diarrhea kills a lot of people every because it dehydrates them. Um, and so that's one of the big problems with the water pollution. Um, okay, so how can we control this water pollution? We can take the dirty water, a very common method. Okay, that's what we do with our sewage water, right? We like the stuff that comes from your toilet or your shower water, that stuff goes to the water treatment plant and it gets cleaned. And for example, I did a tour of the water treatment plant in Athens, Georgia, and they actually release it back into the river cleaner than the water that comes out of the river for drinking. Now, granted, people still don't really want to drink wastewater, but it actually they're putting it in back into the water cleaner than it came out. So collecting our waste in a sanitary manner, so like using a toilet or a bucket or something, rather than just going to straight into a river or whatever your source of drinking water is. having sanitary practices in food preparation, and then also teaching personal hygiene to folks. Some folks don't know that you should wash your hands after you go to the bathroom, or wash your hands before you eat, or whatever. Um, I know, like my 2-year-old, he's like always sticking his hand in his mouth after he's like playing in the dirt. Heck, he tries to eat dirt. So, that's something we're trying to work on with him is washing our hands and being clean, to keep him from getting sick. So these are some statistics for worldwide. There's a billion people. So if there's like over 7 billion people on the planet, that's about 1/7, right, of the planet does not have safe drinking water. About 2.5 billion folks have poor or no sewage collection. So there's their waste is not collected somewhere and cleaned. It's just like, that's going to the bathroom in your water supply, that kind of thing. And each year there's about 2 million deaths due to waterborne diseases. So it's not, it's not a small number. It's a large number of people that are dying from this. So how can we pollute our water? What are the different types? We have organic waste. Organic waste is basically stuff that is not natural, but like fecal matter, that kind of stuff. That would be considered organic waste. Different types of chemicals that can run off into the water, additional nutrients, or sedimentation. So if you have like a lot of dirt going into your water or something like that, that's actually a type of water pollution, and it's called sedimentation. So organic waste pollutants. So we have something that we talk about, biological oxygen demand, and I think next week you'll have a lab that discusses biological oxygen demand. And it's basically the measure of the amount of organic matter in the water, like where you're going to have, if you've got a lot of things that are using your oxygen, basically. If you have a high BOD, then you're going to have most likely high levels of anoxia because you're going to be using more oxygen than you have in your water, and you're going to have very little animal life present. So, for example, there's a dead zone in the Gulf of Mexico, and there's not a lot of animal life there. It had a high BOD, and now there's like lots of anoxia, and that was from mostly fertilizer runoff or inorganic nutrient runoff from the Mississippi River. We can have chemical pollutants. This is actually a river in China. I don't think it's actually the Yellow River, but obviously something's going on with this river. Like, it's not okay, right? There's some sort of chemical pollution going on here. You have inorganic or organic chemicals. So inorganic would be like heavy metals and acids and that kind of thing. Organic chemicals are going to be carbon-based things. So they may be like petroleum or oil or pesticides, detergents, things like that. And the problem with these things is a lot of them are toxic at very, very low concentration. So you don't have to have that much in the water to start killing things. So sedimentation. So basically, if you're going to have a lot of erosion, you're going to have a lot of sediment in your waterways, and that's going to cause some issues. One of the problems is it can cover things. So like if you have animals living on the bottom, or you have some sort of something that needs the sun, it can cover those things up, and then they can't get to the sun. It's suspended in the water, like in this middle picture, like this, then whatever needed sunlight growing at the bottom is not going to be able to get sunlight. Because, plants and things, they can't just move, right? A fish like move closer to the top or something, but a plant is kind of stuck there. And you can see this river, it's had way so much sedimentation that it's not even hardly a river anymore, right? It's just like some puddles. And so we have this thing called bed load, which is basically the amount of sediment that is not carried in suspension, so it's not suspended like in this picture, but it's washed along the bottom. It can like say you have this algae right here that is growing on this rock. That bed load can basically rub kind of like a like a sponge you'd use to clean like a really a really dirty dish or something, you know, it can smother anything that lives in the bottom. And if there's any sort of nice hiding places for critters, it can fill in those places. So then you don't have those nice things anymore. And then we have nutrient pollution. This is a picture, I believe, of the dead zone. I know there's some eutrophication here. I think this is the Mississippi River, and this is that runoff. You see that looks like dark right here? That's that basically the river um, emptying into the ocean. You can see right here all that sediment right there, and that dark green is usually a sign of eutrophication, which we'll talk about in a second. The two main pollutants that run off are phosphorus and nitrogen, and that's because those are the common ingredients in fertilizer. These two pollutants are usually limiting factors in aquatic environments, and so when you have more of these added to the environment, you just have this like huge explosion of algae or plant life, which then causes a cascade of known as eutrophication. Like, look at this. Ew. Like this person's got this really pretty little pool and then this nasty water. So we have recommended water quality criteria. It gives us standards for water pollutants. There's 167 criteria pollutants, and most of these are toxic. We have maximum concentrations, which is a high in concentration, beyond which environmental impacts may be expected. And then we have a continuous concentration, so like a sustained concentration. So you can have like a burst of excess nutrients, which would then be like a, you know, if it got above that maximum, then that would be a problem. Then, you know, it goes down to normal level. Or you could have a continuous level that's like, okay, long term, this amount more than that is going to cause some problems as well. So we would call this upper one, we would call this like acute. Um, and then our Safe Drinking Water Act, this is another one that I would try and remember. It basically is giving you standards for the EPA for drinking water. And it has what they consider maximum contaminant levels. They have levels that like drinking water has to meet. And so like, for example, wherever you live, wherever your drinking water comes from, they have to continually test that water and make sure that they're meeting those standards. These are some, this is another, just some more acronyms, National Pollution Discharge Elimination System. This one's going to give us point source pollution. It's going to worry about point source pollution and give folks permits. Then we have something called a maximum daily load, which is basically, it looks at all sorts of pollutants and entering a body of water and gives us kind of a maximum that is allowed. So let's talk about the things that are living in the water, and then we can kind of work a little bit on eutrophication and things like that. So benthic plants are plants that grow on the bottom. That's what benthic means, is like bottom basically. So all these plants, they grow on the bottom. Because you can have benthic plants that are stuck to the bottom, and then you can have like, you know, like floating algae that would grow up here. Submerged aquatic vegetation is things that live completely underwater. So that would be these guys. These two, they live completely underwater. And then you have something called emergent vegetation, and part of the plant is out of the water. So this is like a cattail. These are like water lilies or lily pads. And then you have this other plant called an arrowhead. But these things are called emergent because they come out of the water. And then we have the phytoplankton, the photosynthetic algae. And those are the things that I was telling you that would live like at the top of the water, that would kind of float. But a lot of times they're at the top, just because that's where, you know, the sun is. So now these are our types of environments. We can have something called that ligotrophic. It's going to be low in nutrients, and you're going to get light penetration very, very deep. So you're not going to get a lot of phytoplankton, right, that floating algae, but you aquatic vegetation, because, you know, water can or sun can reach the bottom. Okay, so it's not just because it's low in nutrients doesn't mean it's not healthy. It actually is fairly healthy, because, you know, you do have this white this varied ecosystem. Then we have problem. Okay, so what happens is you get extra nutrients coming into the water. When you get all that extra nutrients, it usually causes a bloom of algae. Okay, those algae end up using, they use up all the nutrients, and then they basically like kind of like they bloom and then they die. So then they die. When they die, they basically like sink to the bottom right here, and then they start decaying. When they decay, they're going to use oxygen. Um, Bacteria are going to grow, and they're going to use oxygen to do these things. That's going to cause a problem because it's going to deplete the dissolved oxygen in the environment or in this water, and it means that there's no more oxygen left for like fish and other animals like that to grow. And so then you've got this, usually end up with this green, and that's why they call it a dead zone, because there's no oxygen left, nothing can live there, and they call that eutrophic. Um, so this would be like a eutrophic lake. Yeah. There's two ways that we can combat eutrophication. We can attack the symptoms, so we like the growth of extra algae, like we could maybe like sieve off all this extra algae. We could put, you'll see some like neighborhoods and things like that, or like apartment complexes I've seen, they have like fountains to try and aerate the water to try and keep that extra oxygen in there, since a lot of times neighborhoods have really nice, beautiful grass that has been fertilized running into those ponds, and so that causes them to become eutrophic. So they try and use the fountains to kind of create more oxygen. Or you can get at the root cause, right? Or you could just like fertilize less, right? Or reduce the amount of nutrients coming into that waterway. So it just depends on how you want to combat the problem. A lot of places, they still want those really beautiful, nice lawns, and so they just attack the symptoms rather than the cause. So to attack the symptoms, sometimes they will create, this is the picture of the dead zone, by the way. They'll create, take herbicides and kind of spray them on the extra phytoplankton. They will try and aerate, like I was telling you, with the fountains. You can harvest aquatic weeds. They have these boats that will go along and scoop up all that the algae and stuff like living at the top of the surface. Or some places will actually like drain the water and put back, clean it, and put water back in there. So there's obviously you can't do that to the Gulf of Mexico, right? You can't drain the water from the Gulf of Mexico. So they're not really sure what to do with that. If you want to get at the root cause of the eutrophication, limit nitrogen and phosphorus, because those are the things that are causing it. And so you've got to find a way to do that, whether you have something that, like a plant that is at the edge of the waterway that can kind of filter that out, or you have some places like construction sites and stuff, they'll have these little like berms or these like things that they make that they put against like stormwater drains to make sure none of that stuff gets down into the waterways. You could reduce the amount of fertilizer, but you've got to do something to reduce the nitrogen and phosphorus entering that system. The NPDES is just a permit process. I don't even know why I put this slide in here. So the total maximum daily load. What they're going to do is they're going to identify pollutants. I feel like this should have been back a couple slides. They want to estimate the pollution coming from all of the sources. They want to estimate the ability of the body of water to assimilate the pollution, like how much can it hold before it starts having problems. Determine the maximum allowable pollution load, and allocate allowable levels of pollution. So like you can pollute this much, you can pollute this much, we're going to allow this for runoff, that kind of thing. And then how can we recover it? So this lake, I want to say it's Lake Washington. It used to be, yeah, oh, it's right there. It used to be really, really nasty. But they've completely redone done the way they manage that watershed for that lake, and now that lake is totally beautiful. And you can see this is it right here, and it's can be used for recreation, all that kind of stuff now. So you know that you can't fix it a lot of times. It might take some time, and it might take some money, and it might take some effort, which is all things that sometimes people don't want to throw at these solutions, throw at these problems. So the EPA is basically in charge of the nation's waters. The Clean Water Act was a big deal. That's what I was saying, that you should like memorize that one, or not memorize it, but like kind of know what it does. That way, if you get asked about it, you know. Established a program to achieve the goal of protecting and restoring integrity of the nation's waters. It's the one that has those permits. It requires the permits. It has strengthened water quality standards, encourages the use of best pollution control, and has spent billions of dollars on sewage treatment plants. Okay. Except for some reason, Congress keeps being torn on whether or not to reauthorize this act, even though it's done so much good. Um, Politicians are usually, their campaigns are usually funded by businessmen, and those businessmen are sometimes from companies that have to spend money to regulate, um, to like put filters on their factories or whatever, because of these acts, and so they'd rather not do that. The Clean Water Act has actually been one of the most successful in environmental laws. Sometimes when I find positive things about environmental science, I like to try and tell you guys about them, because sometimes I feel like it's really depressing. Like there's all these problems and it's almost impossible to solve them. So there. There's treatment plants. We reduce soil erosion. 2/3 of our waterways are safe for recreation, which is double the number in 1972. And the levels of toxic chemicals in the Great Lakes have also been reduced, which is another good thing.